Hello again, everyone, and welcome back. This is our last lesson of Unit 2. We're going to actually build off of what we did last time and actually put this to use to help us check to see if different functions are inverses of one another, which is a really important thing in math. So what I have here is two functions, f of x and g of x, and we're going to actually see how you did with the last lesson and ask you to find the composition of these two functions. So over here, you've got g getting plugged into f, and then on the right side, you've got f getting plugged into g. So I'm going to ask that you hit pause, try to find both of these compositions. Once you're done, hit unpause, and we'll walk you through it. All right, well, welcome back. And here's what our work should look like. It's kind of intimidating at first, right? Because there's lots going on in both equations. If we are patient and continue to find all the x's, pretend that we're picking them up and creating space, and I like to do that by showing that I have this line there for some new function to come in. Okay, these things tend to work out fairly well, but you got to be patient. It takes practice. We got to make sure that we are doing some of this work on our own. So for the first one, f of g of x, the original function of f, everything's going to stay the same except for this x, right? So if we look here in purple, I have the parentheses still. I have the -2 still. I have the squared still, and I still have the -4. That x that I picked up and threw out, I'm replacing with this square root of x plus 4, and then I have +2, and that's all in green there. So once we have that, we need to think about order of operations. And so when we're the first part of that, and PEMDAS is the parentheses, right? Inside these parentheses, I see I have a +2 and -2. Those things cancel out. So that's the first thing I did here. And then I rewrote what was left over, where I have square root of x plus 4, but all that being squared, and then -4. Squaring and square root undo each other. So those two things cancel each other out, leaving us with x plus 4 minus 4, and then 4 minus 4 is 0, leaving us with just x. And if we look over here where we do the opposite, and I take g of x, take this x out, pull it off the page and get rid of it, and create space for f of x to come in there, we're taking the square root of x minus 2 squared minus 4, but then we have +4, and the +2 is on the outside of that square root. So in this case, when we're thinking about PEMDAS or our order of operations, underneath the square root is almost like we have a big set of parentheses. Even though I didn't necessarily write it in there, we need to solve underneath that square root symbol first. So once again, I have a -4 and a +4 that cancel, leaving me with the square root of x minus 2 squared, just like they did over here. Those two things undo each other, leaving us with x minus 2 plus 2, and the -2 and +2, and with x. There's something going on here. We're getting x in both cases, which leads us into our entire lesson on determining if two functions are inverses of one another. And sure enough, we would call f of x and g of x inverses. And let's look at why is that? So functions that undo one another, and undo meaning they're undoing the different operations, right? If I add, the undo operation of adding is subtracting, the undo operation of squaring is square rooting, and vice versa. And when they undo each other, we call those inverse functions. We can solve for inverse functions by switching the roles of x and y. We're not actually going to do that today, but when we get into further units, we're going to really focus on that piece of it. Today, we're going to focus more on how can we tell if something is an inverse function or not. So because inverse functions interchange the inputs and the outputs, the domain and range are also interchanged, or they're just switched. I think that's a better word here, is switched. And that's what it means to interchange, just to switch something out. So the domain of the original function becomes the range of the inverse. Again, we don't really need that here. We'll focus on that in the future lessons. So what we're going to focus on here is our two functions inverses of one another. And that's what you did in the opener, right? We found that if I took the composite and the composition of function of two functions and we end with x, that's really what we want. That's what tells us this is a function or not. We can also find the actual inverse. We're going to skip that part, so let's not even make a note of that quite yet. All right, so let's focus on A couple examples, and we'll do one that is fairly straightforward and then one that's a little bit more complicating. And actually, before we even do that, let's quickly just talk about how can we tell. So since inverse functions undo each other, we can use our knowledge of composition functions. This is what we talked about in the last lesson. We take one function and plug it into the other to help us identify if two functions are inverses. So we need to check two things. We need to check if f of g of x equals x, and then similarly if g of f of x equals x. If they both equal x, then we can say that those two functions are inverses of one another. So make sure that we are fully simplifying when we are working on these compositions here. So let's take a look. I've got f of x being 5x minus 2 and g of x being 1/5 x plus 4. We can start with 1, so f of g of x, and again, I'm going to use colors here. I think that's especially if you're having a hard time seeing these compositions, the colors make a big difference. So this is saying take f, and instead of g of x, let's replace that with what it equals. That's the whole 1/5 x plus 4. And so this is saying take f, keep everything the same, except for where the x used to be. I'm going to pick it up, throw it out, create a bunch of space for something to take its place. I still have that minus 2. So where the x used to be, I'm going to bring in g of x, which is 1/5 x plus 4. And now we've got to simplify just like what we talked about in the last lesson. So I'll distribute just to what's in the parentheses. 1/5 times 5 is actually 1, so giving us just x. And 5 times 4, that's 20. And 20 minus 2 is 18. This obviously does not equal x. Since it does not equal x, this means that they are not inverses of one another. That's really all that we need. As soon as we find a composition that does not equal x, we don't even need to check the other one. Okay? As long as we find one where it doesn't equal x, that's all that we need to be able to tell if something is a inverse of the other function or not. So the reason is because f of g of x does not equal, that's what this symbol means, does not equal x. So those are inverses of one another. Now, could we have seen this before even checking for the compositions? Yeah, right? If I have a 5, to undo that to get x, I'm going to need a 1/5. Or really, this is like dividing by 5, right? I see a multiplying by 5 and a dividing by 5. So those cancel out. But then when I see a minus 2 and a plus 4, those aren't going to cancel out. But had this been minus 4, we might have actually been able to get something. So when we're checking for compositions, before we even jump in, or excuse me, when we're checking for inverses, before we jump in, we can kind of look at what's going on with the two different functions and decide, okay, do we see the inverse or the undoing of one operation in one function compared to the other? All right, let's do one more together, one that requires a little more simplifying. And actually, if you look at number 2, it is the same thing as what we just looked at. So let's just skip that one. You can cross that off. One less for us to do. And let's jump down here to number 3, where at first glance, it looks a little scary because we got fractions. Now, before I even jump in, I'm like, all right, what do I see here? Well, I see these 2s. I also see a -8 and a +8. So it looks like I might be able to get everything to cancel. However, I'm not quite sure yet. So we need to do some work. So F, I'll use in purple. G, I'll do in green. And so I'm going to take F, where g of x used to be. I'm going to replace that with what it equals, which is 2 over x plus 8. And so now I'm going to copy down F. Everything's going to stay the same, except for where the x used to be. I created a bunch of space. And I know it looks messy. When I bring in 2 divided by x plus 8, we have our composition set up. Now, yes, I'm going to always use parentheses when I plug in, but in this case, they do not matter because there's nothing I can simplify here. And let's not let this fraction really throw us off. Okay, we'll address that here in a second. So I see a +8 and a -8. Those do undo each other, which is nice for us. Now I have 2 divided by x. So there's lots of division going on. When we are dividing fractions, and this is something we probably haven't done in a while, so let's make a note of it. Divide fractions. The way I remember it is we copy, dot, and flip. So what the heck does that mean? Well, let's take an example, and one similar to this. If I have 3 divided by, let's say, 3 halves, the copy means copy the top part of the fraction. So I'm going to copy the top part down. I'm going to rewrite it, 3. And then the division changes to multiplication. That's the dots. So division changed to multiplication. And then we flip the bottom part of the fraction. So this becomes 2/3. Now we have to remember, how do we multiply fractions? Well, it helps if we have one fraction or 2 fractions together. So remember, if I have a number by itself or even a variable, I can always make it a fraction by just putting it over 1. So when I multiply these, I'll multiply the tops together and the bottoms together. So 3 times 2 is 6. 1 times 3 is 3. So I have 6 divided by 3, which is 2. So we need to remember copy dot flip, and then we multiply fractions, multiply the tops together and the bottoms together. We will get more practice with this. So for now, try your best. Okay, we'll always have time to ask questions later. Let's see if we can apply this to our composition function here. So first thing, I'm going to copy the top. So it's still just 2. I'm going to change division to multiplication. And then this bottom fraction that we're dividing by, I'm going to flip it. So it's x over 2, or x divided by 2. I'm going to make this a fraction. So 2 divided by 1. And I'm going to multiply tops together and bottoms together, giving me 2 times x, or 2x. 1 times 2 is 2. And sure enough, I've got 2 times x divided by 2. So multiplying by 2 and dividing by 2 undo each other, leading us to just x. So right now it's looking like these are going to be inverses, but we need to check the opposite composition. So I'm going to actually ask you to hit pause, see if you can do some dividing of fractions, and see if you can end with x. Don't make math up. Make sure you're actually taking the right algebraic steps. All right, so go ahead and hit pause, work through that, and then I'll have your work for you when you hit unpause. All right, so a little tricky here, and I want to make sure that we can get the setup right? Because if we're not getting this part set up, the algebra is not going to work out itself. So yes, this, when we had in the fractions, is a little tricky. We want to challenge you now. Don't think it's going to be this tricky when we actually get to our test, but we can still try. So I'm checking first, is g the same besides the x? So I have 2 divided by x, and that x is gone. So I am replacing that x with this entire f of x, which is 2 divided by x minus 8. And I still have the plus 8 at the end. So in this case, we actually need to take care of the dividing of fractions first. I can't just get rid of this minus 8 and plus 8 because of all this division. So we need to do some other things first. So I'm going to copy the top. The 2 becomes still 2. Division becomes multiplication. And I need to flip the bottom fraction. So it's x minus 8 over 2. Now, when we have fractions, we don't typically put parentheses around the top or bottom, but that actually is really important, because now when I do my flipping and I see 2 times x minus 8, it's not, I'm multiplying the 2 to both the x and the minus 8. So in theory, we could distribute. I did not distribute, rather I just wrote 2 times x minus 8 divided by 1 times 2, which is 2. Because now I have a multiplying of 2 up top and a dividing by 2 on bottom. Those undo each other, leaving us with just x minus 8 and still that plus 8, where those 2 things cancel, leaving us with just x. And thus, these are inverses. So we're going to say, yes, they're inverses because f of g of x equals x, and because g of f of x equals x. And so we are all set. This is a hard example and one that requires some algebra that we're going to focus a lot on down the road. So if you're like, oh, that was a little tricky, I'm with you. Okay, there are some ones that we can absolutely do. So you have plenty of practice in the group practice. Okay, you have another fraction, try it. And remember, you can kind of get an idea before you even start as to what things might cancel. Like here, I'm seeing a cubing and a cube root. They're probably going to do each other. I see a plus 3 and a minus 3, probably going to undo each other. and a -3 and a +3, probably going to undo each other. So I am guessing that this one probably will work out to be a composition. Okay, go ahead and hit, this video is concluded. We are done with Unit 2. Make sure you complete the group practice and the independent practice. And then from here on out, we just need to make sure all homeworks are done and get going on our review for the assessment. Have a great day, everyone, and thanks for watching.